Hello, my name is Derek Burke, System Applications Engineer at Analog Devices. Today we are introducing ADI's E2B 10BASE-T1S technology. E2B, which stands for Ethernet to the Edge Bus, provides the most optimized solution on the market for 10BASE-T1S Ethernet connectivity to sensors, actuators and sub-ECU edge nodes. The aim of E2B is to accelerate the transition to next generation automotive EE architectures with the zonal ECUs and the centralization of processing and software. This is achieved by removing the complexity on the edge nodes using ADI's low complexity Ethernet technology. E2B incorporates a fully compliant 10BASE-T1S IEEE 802.3 CG Ethernet PHY, as well as the MAC supporting point-to-point and multi-drop format. The bus operates at 10 megabits per second over single unshielded twisted pair cabling. In addition to this, it includes ADI's low complexity Ethernet technology, which enables removing the MCU and software on edge nodes to achieve a complete hardware solution. All software can be centralized back at the zonal or central ECU. This brings some very significant system advantages, including an all hardware edge node, which simplifies implementation. Additionally, it reduces latency and boot time, lowers power consumption and reduces the form factor. Centralizing of software to one area rather than distributed over the edge nodes makes maintenance easier, along with simplifying over-the-air updates. In our demo today, we show real-life applications represented on our car model. Two zonal 10BASE-T1S networks are represented here, a front zone and a rear zone. A zonal ECU implementation here consists of an E2B 10BASE-T1S device connected to a microcontroller via the new Open Alliance SPI interface. The zonal ECUs are then connected through the Ethernet switch back to our Surface tablet, as represented here by the cloud. This showcases one of the key advantages of moving to an all Ethernet network, removing the need to add gateways in the zonal ECU, which would be required if using legacy networks like CAN, LIN, etc. Now let's look more closely at the hardware on our car model. The front zone with 4 E2B edge nodes consists of 2 radar devices measuring distance, 2 LED matrix panels for lighting applications. The rear zone with 8 E2B edge nodes consists of 2 BLE modules for keyless entry application, a radar module for presence detection, 3 LED strips for ambient lighting, and 2 motors. Note that all of these edge nodes use E2B in low complexity Ethernet mode, meaning that there is no MCU used in the edge node for the Ethernet communication. The demo illustrates some of the wide variety of use cases that can be addressed by E2B 10BASE-T1S. Physical layer collision avoidance (PLCA) is implemented on the 10BASE-T1S network to maximize data throughput, and as the name suggests, avoids collision and thus preventing the need for retransmitting data. This can be observed with the radar sensor and the LED array, which are demonstrating a low latency control loop. As I approach one of the radar sensors with my hand, data is sent back to the zonal ECU, where the distance information is calculated, and the information is then sent back to the LED strip over the 10BASE-T1S network to reflect the distance. When no presence is detected, the LED matrix returns to a static pattern. This showcases a low latency control loop for headlight functionality with the software centralized back in the zonal ECU. Next, on the rear zone, we show BLE modules used for keyless entry applications. I connect my cell phone to one of these BLE modules, and the ambient light LED strip indicates my phone distance to the car. As I move, you can see the change in distance reflected by the lighting strip. Again, both the BLE node and the lighting node do not use an MCU for Ethernet connectivity. The radar module in the back is working in presence detection mode. This acts as a kick sensor to start the 2 motors on the same 10BASE-T1S network. The central ambient lighting strip also reacts to the presence detection. The motors work in sync with each other as the 2 E2B devices implement a hardware version of IEEE 802.1AS, time-sensitive networking for multi-drop configurations. With TSN enabled, the motors on the two different remote nodes start, rotate and stop in sync. Now, when I disable TSN on the GUI, you can see that the motors will go out of sync and will collide as they no longer have a common time base. ADI's hardware implementation greatly simplifies bringing TSN to remote edge nodes. With our GUI, we demonstrate the ability to support over-the-air updates, a key advantage of moving to the all Ethernet connectivity. Here, we centrally control the different applications, turning on or off features and selecting light patterns. This shows the seamless transition from one Ethernet technology to another one using a simple switch with no gateways required. Our E2B 10BASE-T1S products are available for sampling now. Please contact your local analog devices representative for more information.